Hello, can you hear me? Okay. So this is the dynamic access control deep dive and extensibility talk. So thank you for coming. We brought you some wonderful weather. I'm sure you've heard plenty of weather jokes already, so I won't go into that. But thank you for managing this. My name is Dave McPherson. I am a program manager on the Windows security team, and I've been on the Windows security team in one form or another since 2001, and been through a lot. And I work primarily on authentication and authorization technologies. If you've ever heard of, let's say, SSPI or Authorization Manager, Role-Based Access Control, then maybe we've crossed paths in the past. And what we're going to do today is go over dynamic access control. Kind of a key feature from the security or the server side and the security side of Windows Server 2012. Has anybody here heard of dynamic access control? Okay, a few, maybe I'd say a 15%, but that's not a problem because we're going to go into it in depth. We'll do a quick intro at a high level, and then we'll dive into the pieces of it at a low level, and then we will, over the course of the talk, I'll point out where the extensibility points are, and then we'll see some of the extensibility that's already been done. So in this, we'll jump into the new classification features in the file classification infrastructure. The central access policies, a new addition to Windows that should be interesting. A new feature, a very interesting feature called staging policies. We'll walk through the flows of how these new claims that we'll talk about get authenticated and travel around. And then, by then, you'll be very curious about token bloat and what the story is there. So that's what's on tap. So dynamic access control, really, when you think about that name, it doesn't sound like a particular feature. And it's not. It's a big bucket for several different feature themes and scenario themes here. The first, really, of these that come together into dynamic access control is data classification. The data classification problem really is that there's bunches of data out there that's in some cases ancient and in some cases irrelevant, but in many cases, potentially important. So there's a concern to get it properly secured. And it's just living out there, and it's growing and growing and growing. So all of a sudden, file classification or data classification has become a very aggressive technology. The next is expression-based access conditions, and this might surprise you if you haven't seen these yet. But what it is we've had for a while now, we've needed something more expressive than the Windows group model, right? So something that could give us a better way to express our authorization intent than what we could say easily with groups, and in a centralized way. And then expression-based auditing. So access control sister is auditing, and the same expressions that are useful to describe authorization intent are useful to describe auditing intent. And there, the concern is not just forensic analysis, but also compliance, where just showing an audit policy and showing intent is actually important. And then lastly, the encryption story. So once we have this perimeter secured, what do we do in order to make the data, when it leaves the perimeter, stay secure? And that's going to be about RMS encrypting the files as they leave. And I'll talk all about this in the context of files and file server, because that is the customer for dynamic access control. The technologies here can go beyond that anywhere. But in Windows Server 2012, the end-to-end scenario is file server. Okay, so that was the scenarios. These are the components, the features that are kind of the conceptual building blocks that we'll be looking at. This is kind of a primer slide, right? So this will be the first kind of coat, and then we'll go deep. The first is expression-based ACEs. So we've all heard of, who's all heard of security descriptors in Windows? Okay, so there's still some. In those, there's ACEs, and now they have expressions in them, which we'll talk a lot about. Then there's user and device claims. Now, probably that's not a new concept to most of you, this notion of claims, but it is a new concept in the scope of a security descriptor, so we'll be going into those, and the conditional expressions that they can be used in. We'll talk about classification enhancements that have been added to the file classification infrastructure that allows us to take a look at a big swath of data, of files, unstructured, and get them labeled so that then we can use our conditional expressions to put appropriate access control on them. And then a new concept called central access and audit policies. So this is something new in AD that can project policy over various different group policy scopes. Okay? And then access denied assistance. Now we won't go into that in this talk, but it's part of the overall piece here. So I'll mention it some here, and we can in the Q&A if you want. What this is you know how in SharePoint that if you go to a SharePoint site, you don't have access, you get a page that says you don't have access. You want to request access. Well, file servers never had that for all these years. File servers never. You get access denied. That's just it. You're done. And usually you were literally done if you didn't know who ran that server. So what this does is it provides a way for the administrator to provide some guidance to the user that they might be able to self-remedy a situation, like, oh, silly me, I didn't use my smart card, or even just request access. Email gets sent to the data owner. Okay. Now again, that's not we're not going to go deep in that in this talk, just because of the volume of other stuff. So first, the glue that kind of ties all these different things that we'll talk about together are these expressions and expression-based access policies. Okay, so we'll start there. And expressions have operators, and they also have things that they operate on. And in this case, it's going to be these three things: user claims, device claims, and resource properties. Okay, so first off, user claims. And again, I assume folks already kind of have heard of claims. What's a Microsoft product that uses claims? ADFS, cool. And sure enough, in the internet and cloud world, the claim model's kind of already established as the way to describe a user principal as they come to you and ask for permission to do something. Well, now they're in Active Directory, and they can be used in Kerberos, right? They'll show up in Kerberos. So then some people say, what's the difference between a claim and a group? And really, a claim is just a more flexible form of group. A group is really in Active Directory a SID with a RID, right? Where the RID is just an increment that particular issuance of the SID got. So it's very, very tied to that particular domain, and it doesn't really have any really semantic information for you about the nature of the thing it's saying, because we all know it's a group, right? But that can't really be used in flexible ways, right? And we'll see what I mean by that. So examples of claims would be those user attributes that are already in Active Directory, things like the user's department being finance, or the user's clearance being high. Right? The next is device claims. Now those are just like user claims, except that they apply to device objects. Okay, so this would be, is the device managed by the IT group? What department is the device provisioned for? And then lastly, the last thing that we're going to operate on in these conditional operators is resource properties. Now these look and feel kind of like claims, but they're not talking about a security principle. They're talking about a file, right? So, or an object. So, but like a claim or a group, there are a thing that we trust being said about this file or object from somebody that we trust. and in fact, the security descriptor. So these are the things with which we compose a conditional access policy. So here's one, your first conditional access policy, for those of you that haven't seen them before. The thing to note here in yellow is this, what I call the applicability predicate. And that, remember that, but it's not a good word. I don't have a better word to say that you'll quickly snap to, and we will talk about it. But what that means is this is when this central access policy applies. If this resource's impact is not labeled to high, then this policy steps back and is not relevant in the access check. Okay? So it's applicability predicate. And then we have our actual central access policy when it is applicable. This one's saying allow read and write if the user's department is equal to the resources department claim or property and the device managed claim is equal to true. Right? So obviously you could never do that with a group model. And even trying to do that with a group model would be, I've actually mapped it out once and it was intractable to try to pull that off. I mean, especially when you talk about getting the device attributes in there. So this slide is not as intimidating as it looks. Really the point here is that what do we have before and what do we have in Windows Server 2012? Right? Prior to Windows Server 2012, we could only make access control decisions based on groups, right, as they were. And we didn't, for example, the attributes in Active Directory, user's title, user's department, couldn't use those, even though they were already there. So that led to groups being made to manage things that in some cases we already had. It led to a lot of groups. These groups also have these kind of constraints, such as you may be familiar with, there's global groups and universal groups and domain local groups and machine local groups. And then there's kind of guidance about when to put what in what. And that's gotten kind of confusing. And also each of those groups has scope. So a domain local group can only be used, or can only be used within that domain. It doesn't show up anywhere else, only on servers in that domain. A domain group, global group, can show up elsewhere, but can only hold users within its source domain. So it just got confusing. With the claim model, they're tied to the user, so that they go wherever the user goes. So that scope issue is just not there. And there is no good way to go across realms with these groups. Remember, they were really tied to the domain model. So if we were, first trust each other so much that we're joined at the hip, right? Then we had a model for that. We could cross-forest trust, and we could set up ACLs and give people access. But unless we trust each other that much, then we don't really want people to be able to look into our Active Directory, look at what our groups are named, look at who's in our groups. So the model is just too wide in terms of the trust, right? So there was no way to transform that with SIDS. Arguably we could have made it, and in a sense this is doing that, but it's doing it in the context of claims because that's kind of where it's going to make sense going forward. And then there was no way to really bring in the access of the user's device. And if you think about this, this probably going forward is going to be really important. Like in 10 years, won't surprise me if it's just a requirement that we know things about the device that the user's on. Especially think of BYOD, where people bring their own device in that they bought themselves, and goodness knows what's on it. Before I give access to my finance data, I might want to know some things about that device. Does it have TPM? Is it secured with the right version of virus software and such? So it won't surprise me if these get really important going forward. Now, in 2012, right? This is kind of the after, right? We do have this notion of claims and attributes being used in the policy. And these policies can be used cross-forest through these transformations. They can create these intent scenarios that before we just weren't able to do. Now you have one here, and it's using just groups, and there's a reason for that. But so first look at this one here. Allow write if user.member of the finance group and user employee full-time equal full-time and device managed equals true. So you can see we could never have done that prior to Windows Server 2012. And it's also important to note that groups aren't going away. Groups are really the original claim, right? And they have some really nice properties that claims don't have. For example, they compress really tiny in the right context. If I've got 100 SIDs from that DC, I can compress that really small and then just keep the RIDs around, right? So there's some really nice attributes. Also, the delegation administration model for groups is very mature. And the ecosystem for groups is very mature. And obviously with claims, not so. So they're not going anywhere. I think they'll be around for a long time. So then we get in deeper into the expression-based ACEs. Now, this is the situation prior where we could only effectively do an OR. And if you think about what's going on in ACEs in a security descriptor, in an ACL, you have this ACE, and access is kind of given, and if this ACE gives access, or this ACE gives access, or this ACE gives access, right? So where those are groups, right? And that model leads to a thing called group bloat. Now, to illustrate that, consider an organization that has 500 projects, 100 countries, and 10 divisions. This might sound like a contrived example, but it's not. It's actually, the numbers are lower to protect the innocent. I've had 2 customers that wrestled exactly with this problem, and then there's others that would have, but were warned off. In order to, let's say that they want to give access based on this tuple of the user has to be in the right project, in the right country, in the right division in order to get access. That would require, in the group model, a group matrix of 500,000 groups. And again, that's not contrived. This one fella told me that he stayed up all night. He wrote some scripts to make some groups, look in Active Directory at people's attributes and then populate groups. And then he even took the important files and put those groups on them in security descriptors. And then in the morning, nobody could log on. Right? So this has really happened. And then people have been warned away from this. Just with the AND operator, just that operator, we can get that down to, from 500,000 groups to 610 claims by the virtue of this expression. If the user's a member of Project Z and they're a member of the UK group and they're a member of the engineering department group, that ANDing, right, which kind of visualize intersecting, right, creating a little virtual group there, reduces that need down to just 610 different group objects. So that's significant. That you could, over time, not right away, but over time, we believe that the dynamic access control can really get a handle on this group bloat problem. And then we can go further with claims and expressions too. If we just have 3 claims of project, country, division, and we just create a policy that says if the user's project, country, division equals those of the resource, they get access. Right? So now, effectively 6 objects, and 3 of them are on resources. So clearly, this is a powerful way to express policy. Okay? So we mentioned the AND operator, and we certainly get a lot of power out of the AND operator. But there's a host of other operators too. So in terms of categories, it's just your classic standard conditional expression logic fair. Where there's logical operators and relational operators. Logical operators compare logical values and spit out a logical result, such as true and true is true, right? And then relational operators semantically compare, based on some algorithm that the operator implements, 2 values and spits out a true or a false. Okay, so is 7 greater than 6? and then comparing the actual values. Now you can see we got a lot out of just the and there's a wide body here of operators. And note that not star I have down there, all of the relational operators you see there have a not aspect too, okay? So we can make some pretty, really lock people down. When we did the user testing, one of the IT admins said, you can really lock this down. And I agree. You can really dial in that access control policy that you want. So going even deeper, how did this kind of come into Windows when you think about it? There's areas that we just don't want to breathe on much in there. Well, it came in through the callback ACE, which is kind of this artifact from back in the day. Has anybody heard of a callback ACE in this room? Okay, not a surprise. I gave this talk once before and one person had heard of it. But what it was this really cool feature in Windows Server 2003 that allowed for an ACE type that the application could put custom data in, this little chunk called the application data buffer that you see there. Whatever they want, shove in there. And then during the access check, they could give us a callback and we'd call them and they could do whatever they want, right? So they could check, something online to see if hurricane warnings were high or whatever, right? Well, it didn't get widely used, but it got used here and there. And that's the nice thing about it is the OS is trained for it. So when down level, for example, on the file server where it wasn't supported, they'll see it and they'll say, oh, I don't support that. If you're on a Windows, Server 2003 file server, they'll see it and they'll just back away from it without breaking, right? So it was ideal. And now, SDDL. I know some folks have heard of SDDL. Anyone? SDDL? 1, 2, okay. SDDL is the security descriptor definition language, originally kind of designed to define security descriptors in text. Okay? If it came along 5 years later, it would be called XSDDL, and we would have made it XML. But it's not XML. It kind of predates that. It's a way to define. Some people got really good at it. Some people can look at a security descriptor in SDDL and know exactly what it means. For example, this what I have here in green isn't a whole security descriptor. It's an ACE, right? Some IT admins, not even developers, some IT admins got really good at this. This one is an allow ACE with container inherit, object inherit, giving full control to authenticated users. In green there, that's what this ACE is doing. So you can see if you do that every day, you catch on. Now, it was never really meant for humans, right? But humans caught on. So how do you add the conditional expression into that? Well, it's not a big change. We changed the ACE type from an allow ACE to a callback allow ACE. Okay, you see that purple X, and then boom, you just have this big conditional expression, right? With some syntax there that humans might get puzzled at, but not too hard to read off the thing, right? So that's really what's going on in SDDL. Now that's also integrated into Access Check, right? And that's what enforces these conditional expressions. So maybe not as big a change as you might think. Now, in terms of extensibility, the model for the different extensibility scenarios here include I'm writing an app to manage authorization policy, right? So I have to manage these security descriptors, and that involves API that already exists to manage SDDL, these strings, right? Those then are used to put into an API called add conditional ACE, right? So that callback ACE thing's abstracted, conditional ACE. And then these resource attributes that have to go in security descriptors as well. More on that later. There's an API to manage those. So this is Win32. So for better and for worse, it's not as broadly available as it might be if it was in C#, but it's very doable. And then in terms of managing claims in Active Directory, there's PowerShell, or if you're an LDAP guru, there's LDAP. And likewise, for managing central access policies, there's PowerShell and LDAP. Okay? And the scenarios there are, and we'll see at the end, some of the partners that have already come on and done things. But for example, Axiomatics has this model where they take XACTML policies from an XACTML server and convert them to SDDL policies and then shove them into a central access control policy in Active Directory. Okay? That's just one example. There's lots of extensibility points. One of them is file classification. Now, silo everything I just said, because we just left the intro to conditional expressions part, and now we're going to talk about the file classification infrastructure. It all comes together into dynamic access control, and you'll see why, but just to make sure we all catch that transition, the file classification infrastructure originally shipped in Windows Server 2008 R2. And it was kind of a hit. It allowed for rules to be defined that would look at data and put classification on it. But it had some limitations. You drop a file in, it didn't, boom, get classified. So it wasn't continuous. It ran at like 2 a.m. or whenever you scheduled it. Right? It was not for access control. It was very much not a security feature. They were the tags or properties were stored in the alternate data stream, in a alternate data stream on a file, which is, and anybody that has write access to the file can write and change the claim. So it's not a security feature in Windows Server 2008. And also there was really no UI for manual classification. Now, you can imagine in a security setting, if you just put you just put PII, personally identifiable information in there, somebody's credit card number or their address. You say, this is PII. You'd have to have some UI, some way to go tell the system to tag this file, right? So that wasn't there. It wasn't for that. So in terms of how it's been changed in 2012, it now has a UI, right? Now this is group policy driven, so unless you turn this on in Active Directory, you won't see this, and it won't be on at home in Windows 8. But it will actually be, when turned on in a domain, show up on clients, because the client will have to label a policy. And then they live, okay, so if it's going to be used for a security purpose, we have to have somebody who's going to arbitrate the nature of these properties. If I'm going to say you can have access if the file's labeled HPI, somebody had to define this thing called HPI. So they're defined centrally in, guess where? Active Directory. And in the future, we might make that a little more granular, but that's where they're defined for now. Now they have what's called I don't want to get this wrong. Near real-time classification, which means that you drop a file in, it gets classified very quickly, but we're backing off of the word real-time. There's in-box classifiers, and then there's third-party classifiers, and now those were there before too. This is really where I was kind of blown away. Folks like RSA and Data Global, because I'm a security guy, and I wasn't kind of aware of the depth of the file management world. But they have classifiers that plug into FCI, that can look at 20 years worth of data that have been thrown in some repository, and they can filter out the classifications at a granularity that blew me away. There was ISO 7423, for some specs that exist that the file has to be classified for. Just an amazing matrix of classification that can be done looking at data. Now you can see why that's useful, right? You got all this data out there and you don't know what's in it because it's just been thrown on these servers. You can see why it's useful to have a very mature classification infrastructure or classification tools that can go analyze that data. It might take a while, but once they do, they can tell you where your specs are, where your specs that related to a particular e-discovery situation are, right? So it's pretty cool stuff. Come on. And also a change is that they're for security. Now this is done. So I told you that in Windows Server 2008 R2, they were in the thank you, yes, alternate data stream. Where do you suppose they are now if they're going to be used for security? I'm sorry? They're in the security descriptor. That's where we put stuff for security policies. And where would they be put in the security descriptor? If anybody wants to take a stab. It's in the, it could really, that's kind of a trick. We could have put it anywhere, but we put it in the SACL, which used to be kind of the auditing place. If you remember your Win32 security descriptor layout, the SACL's where the audited policy went. Well, that's where these are living. The reason is because we're used to having a high bar for who can manage these there. So the system is real jealous to protect who can touch the SACL. And so resource attributes now, if they're security resource attributes, are stored in the SACL on the security descriptor on the object, which means we can use them for security. And they have now this notion of file management tasks. These have been improved so that you can get data, and based on the event of getting a certain type of data, you can define the nature of that event and the nature of the response. You can do some work. All right. So almost as soon as the original FCI was released, the request came in for RMS encryption. Right. So based on, I want to encrypt based on the fact that this data has PII in it. Right. So that now is out of the box. You can set that rule up to RMS encrypt files based on XYZ as a file management task. As soon as somebody drops a file into a file server. Okay, so that's FCI. Now we're going to switch over to central access policies. Okay. Now this is where it gets really different. Up until now, we haven't really had a model for centralized access control in Windows, right? For the most part, particularly for the system resource managers like the file system. And this isn't really saying that now all of a sudden the Active Directory administrators are going to become the access control administrators. This isn't saying that. But if the organization wants to define what we'll call outer perimeter or safety net policies because of usually compliance, now they can say that at a broad level across a domain or a forest. Okay, so they can say things like, in order to touch a finance document, you have to work in the finance group. And they could, I don't know what the rest of the policy is. Maybe the team owners and the project owners are going to actually do the day-to-day management of the ACL, right? But the very broad level, the InfoSec folks can say, in order to see a finance document, you have to be a full-time employee and in the finance group. Right? So here is how we define a policy. It's done with a little bit of abstraction to allow for a little bit of flexibility. There's this notion of a central access rule, right? And here we see three. So the first one there is this blue rule that is called high impact data. And what this says, if somebody's clearance is high, first off, I'm sorry, there's my applicability predicate there. Resource impact labeled high impact data. Then the user's clearance has to be high, and the device that they connect from has to be managed. Okay. The next rule is the personal information rule. So this is where it has personally identifiable information in the file. If that's the case, then only members of the PII administrators group and the owner can access the file. That's what this rule is saying. Now these are just rules that some corp might define. These aren't rules that shipped in the box, okay? And these are example rules. And then we have this information wall rule, which says that if there exists a department label on that file, a department property on that file, then if any of the user's department's tags equal any of the resource department, then they can have access. Okay? Note that intersection there, if any of, it's one of those operators I mentioned but didn't go into, the user's claims match any of this particular set of resource claim values, then they can have access. Those are then the kind of the rules that can be used to define a policy. To define a policy, we would put some of those together. Now, let's say in this hypothetical organization, they have the standard policy, which uses the high impact rule and the personal information rule. Okay? But in this organization, let's say, that the finance department's different and they have higher standards. So they add to this they add to this the information wall rule. Okay? So there's two central access policies in this organization. These are then, via group policy, pushed down to file servers where they can be applied onto files. And then they're controlling access on that files. Now, they're not the only thing controlling access. The ACL's still there. Remember, these aren't trying to take over that job. Right? You can imagine taking over all those different scopes of resources, all those different file servers, all those different folders. That's not what this is trying to do. It's trying to set these policies that can be stated broadly. And allow some compliance level InfoSec group to get them established. So, how does the file access check actually work? Well, this is prior to central access policies, right? So as you know, you go to access a file on a file server. The first thing you do is set up a share, and the share permissions are checked. And if you pass that, the share is created. Then the SMB server will get the file security descriptor and do an access check on the file for whatever it is you requested. Right? If that works, you get access. With central access policies, there's just one more gate. Right? One person suggested we call this a gauntlet, the feature, the gauntlet, because there's just one more gate of things that you got to get through. It's a central access policy now. Okay, so we'll see that in play right here. This is kind of the temporal order. We come in through the share permissions are checked. Then if the SMB server is happy, then it will grab the security descriptor. If it sees a central access policy reference, now I mentioned that that was pushed down by group policy, so it's not going off into Active Directory during the access check looking for policy. It was pushed down by group policy, sitting there cached in the registry, and even cached in the kernel. Okay, so it's fast as we can make it, and if it sees that reference, it'll run through those rules, and if they apply, because the applicability predicate says that this applies to this particular resource, then the rule will be executed, and the user has to pass that rule in order to get that permission. If they come out of that with some permission, then the NTFS ACL is checked, just old school, right? So then, and if that works, they get access. They get the intersect of all those, right? So if you ask for read and write and delete, let's say, you have to get it from all those in order to get access, okay? Well, now, it's already been the case for files and shares. You got the tighter of the two, right? Now, it's true for central access policies as well. Now, staging policies. This is one of the coolest features of this whole scope of features, because it's kind of one of the more innovative, I think, amongst a host of innovative features. It's just, I think this one has appeal to me because I've had a lot of customers that wouldn't deploy things because they were afraid they would break the world. So this is a way to not do that, right? So let's say you set these up, you set up these central access policies, and I showed you how they stream through group policy, they hit some file server, they get applied, and now all of a sudden they're controlling access. Well, who did I just hose? Who did I just break? Will I get fired, right? A lot of people are not going to want to deploy those, right? And as I've been told, the process of setting up a staging environment is both expensive, right, and not perfect in terms of creating the actual real-world data. It's just, you get a simulation, you don't get real data. So what staging policies allow you to do are within the actual security descriptor, within that central policy that we talked about. Imagine that we have these claims, right? Now, on the left here we have our user claims, on the right we have our resource properties, right? We have a central access policy. This is all old hat for us now. We've already seen that, right? But now we can add to it a staging policy. It's just another central access policy, but this one's kind of not really doing anything. It's just there to sit in the security descriptor so that when access check happens, it will throw an audit event if there's a delta, right? If there's a change one way or another in terms of what this policy would have done were it the policy, right? So here's an example of an event. I've scoped it down to make it somewhat visible. It tells us who would have got host or who got access that maybe shouldn't have. It tells us what the resource is. And it tells us the nature of the difference, right? So imagine, question?
How are those called out differently in the STDL?
How are they called out differently in the STDL? Which they?
Staging.
In the staging policies? These are actually in the central access policies. They can be defined, it looks just like another central access policy in STDL. By context, they're delivered down to a different chunk in the registry, right? Kind of a node next to the central access policy node so that we can see it there and apply it if necessary. So the STDL doesn't distinguish it. It's actually a meta structure that keeps them associated next to each other. Good question. Okay, and it also tells us the rule that caused this, right? Which you can see if there's lots of rules that would be relevant. Okay, so you can run this for a couple weeks, maybe a month, whatever, and get some data, find out if you would have caused a problem by deploying this access control policy. So then into the plumbing in some of these cases. This is where some people have been particularly curious about how things have changed. The first is the token. So if you're familiar with Windows kind of process model and access control model, you've heard of this thing called the token. Well, these extensions are in Kerberos. So the claims flow in Active Directory through Kerberos enhancements, both for claims themselves and for this thing called compound ID that allows for us to, we'll see that, I'll save that. And then once we have these claim-based tokens, you can see now that there's new chunks in the actual NT access token. So you can see the old token, the smaller one, and the new one now has a user and a device area. And in the user device, in the user area, there's now claims, and then in device, there's now claims. So pretty intuitive when you think about everything I've said. Now all this lives in the token, and we can look, token's a kernel object, so other apps can't get in there and mess with it, so we can do access checks based on that. Let me check yes, I already did. All right, so here's the model, kind of how this comes together. InfoSec and AD folks in the corp get together and say, what are those policies that compliance needs us to deploy? And translates those compliance requirements into claims and policies, right? And then they put those into Active Directory. Now that's actually kind of a serious work task. That's not something that can just be done willy-nilly. It's something that the corp has to actually think about. What's our claim model going to be? Not because you can't change it, but because it's going to be used broadly over the corp, or over some range of group policy servers that you define. Once they're in Active Directory and a user attempts to log on, they get a ticket. It contains their groups and their claims. They take that to a file server, and the file server does an access check, creates a token, does an access check. Now, what about, okay, so now we're going to go into a series of flows so that you guys can see how this kind of fits in the environment. And the Kerberos flow for pre-Windows 2012, this is a review, was just user wants to go to a particular file server. So they take the SPN of that file server and they go to the DC and they say, give me a ticket. Right? And now, I'm sorry, first they log on to the domain and they get their ticket granting ticket. Then when they want to go to the file server, they present that ticket granting ticket, and they get a ticket to the target server, and they authenticate there. Now note that there's a machine ticket, the machine account in Windows logged on, and then there's a user ticket, okay? That machine account logon hasn't done much up until now, but it's important for where we're going. So, the Kerberos flow with user claims. User wants to go to a file server. They get a ticket to the file server with their claims. They take that same ticket to the file server, they get access. So this is just, we added claims to the ticket. Nothing special other than the claims are there and that they can be used in access control. But what if we have pre-Windows 8 clients? You guys think that maybe there might be some pre-Windows 8 clients around for a while in corporations? Well, if there are, just in case there are, there's policy that you can set to enable the file server to go back and get the claims if the user doesn't bring them. It isn't just for Windows 7 or even XP. Even a Mac device could do this because they do have, they can't authenticate with things like NTFS, right? So if the user is using NTFS, well, if the file server can identify them, this can work, right? They'll get their, if it's a Windows box, get their ticket, take their ticket. There's no claims, and this server is labeled to use claims. It does what's called an S4U to self. Curious, has anybody heard of S4U to self in here? That is a Kerberos extension that allows for you to, for the server to go get a ticket to itself. Okay, and it's useful for scenarios like this. Okay. And then with that new ticket, they now can do the access check for the user. Okay, with claims. This user, again, could have been on another device that's not even a Windows device. But it did have to be authenticated. All right, now what about compound identity? Compound identity is not something I talked a lot about, but when you think about it, it has to be there in order for us to do this device claim thing. What we're really doing is we're taking that ticket of the ticket granting ticket of the machine and the ticket granting ticket of the user, and we're presenting both of them to the DC. This is an extension to the Kerberos messaging model. And we get back a composite ticket that has claims and groups for both. Send that to the Windows Server 2012 file server, and they got access. Now, this slide's actually the across forest boundaries. Since we're doing claims, and since claims already have a lot of precedence for transformation, it's important that we provided transformation for the claims across your forest boundaries, right? So the way that works is you want to go to that file server that's in another domain, another forest. You go to your DC, you get your referral ticket. That's standard Kerberos. That sends you off to another DC to get a ticket to the target server. It comes back with claims. Again, those claims could have been transformed or completely zapped out of the ticket or a bunch added, right? Or left alone altogether. And then the user gets access or doesn't. What about the cloud? How do these claims that we just did in Active Directory? I've talked a lot about Active Directory. What is the story for the cloud? Well, today you log on, you go to your DC, you get your ticket, granting ticket, you get your ticket. I say, I want to go to the cloud. Well, you go to the cloud and you try to present that. Of course, you don't even have a ticket for it because the DC couldn't give you a ticket for the cloud server. So it doesn't know you. It can't authenticate you. It doesn't even use Kerb. So it just says 401 and you fail. But there's hope. You can go to an ADFS server. Now, what's that redirect done based on? It's ADFS redirection can be done based on maybe it's a smart app. So the app knows, oh, I know where my ADFS server, or based on policy, I know where my ADFS server is. Or it can be one of those web pages that says, do you want to use federated authentication, right? But if that's there, we can then take our ticket, transform it into a SAML claim via ADFS, a SAML claim bag, and take that to the cloud, who in this case would have to accept the SAML token. But that path is there. So that's a lot of stuff flying around in Kerberos tokens, right? A lot of claims stuff. So then the question is, what about token bloat? And to approach that, first we have to factor the problem a little bit. Excuse me. Now, there's been kind of several manifestations. Back when we only had 4 gigs of memory, virtual memory, to play with, it really mattered how much token, a server, how many people authenticated to it. Lots of people come authenticate to it. It kind of mattered how much virtual memory was taken up by each token, right? That kind of token or bloat problem has gone away with the introduction of the 64 gig address space and other enhancements in the system, such as better sharing. The other one is that the other notion of token bloat is where SIDs on the wire, or I'm sorry, the size of packets on the wire, size of that Kerberos ticket, say, right? How big is that? That one's still a problem sometimes. If you've got a lot of groups, you can have this ticket bloat thing, and you go to say a web server that uses integrated auth or RPC server, and it could fail you because the ticket's too big. Okay, so that's one we need to talk about. And what we did there is several things. So in terms of ticket bloat, I should point out that we do expect initially, I mentioned that dynamic access control and that these claims and operators can theoretically eventually drive down the number of groups, right? But in the short term, it's not going to happen. In the short term, there's still going to be all the need for these groups that talk to older resource managers. So we can actually expect in the short term anybody that uses claims to actually see some growth. But Windows 8 has a lot of improvements to address this. One is we do compress these claims, right? So these all this claim data, which is very often strings, get compressed. So far as they compress nicely. Secondly, there's types of SIDs that in the past we didn't actually compress. I mentioned that if you had more than 1,024 SIDs, maybe I didn't mention it, that was a type of limitation of the ticket prior to Windows 2. Well, that actually still exists. If your domain, the user is a member of more than 1,024 SIDs, they have group bloat and they fail to log on. But that doesn't actually get that big in terms of a ticket. It only ends up being around 10K. So that wasn't really what was causing most of the token bloat or the ticket bloat, right? What was doing it was resource domains, right? And domain local groups. When you go to a target domain, you get more groups. When you get that ticket granting ticket, and you get group expansion in the target domain. And that wasn't bounded. And that where it could grow up to 48K, it could grow much bigger. So now in Windows Server 2012, those are compressed. So we expect folks are getting a lot of help right there. And remember earlier, I said they compress nicely. SIDs do compress nicely. That's one good thing about them. Also, there's been some buffers in the system that have been part of a problem, and we've increased those buffers to allow for, and this is particularly some RPC scenarios, to allow for tickets to be bigger. And then we've added audit events that allow you to kind of set a warning layer that say, if the ticket starts getting this big, I want to know about it. So you don't have to have a failure before you can start working on the problem. Okay. But let's look at claims in terms of real numbers here. Now, first off, I have to point out these aren't real numbers. These are worst case scenario numbers. Because it's compressed, and I can't really, guess the compression, I'm just going to pretend they're not compressed. Okay? So this is worst case in that sense. So one claim, uncompressed, adds 242 bytes. Okay? And then let's say we used 5 claims, and with a mix of types, a Boolean, an integer, a string with some multi-values, and a string with single value. That adds 970 bytes, uncompressed. Okay? So that's starting to get interesting. Then we add 5 claims and 2 device claims. This adds 1374 bytes. So now this is a K. Now this is getting, this would be something to be concerned about. So again, as I haven't said enough times, it will be compressed, but still, let's look at what's going on there. So given that that's compressed, given that the resource domain groups are now compressed, and given what we've seen so far in our testing, we don't see spikes in or large tickets. Okay, the compression seems to be doing well, and so we're, of course, this is something that we have to watch. We're changing the size of the ticket, right? But so far, the testing is that we're not seeing big changes in ticket size. Okay. And again, we do have audits in place now that will tell you before there's a problem. Now, the other nice thing about this feature is I've talked about a lot of different chunks that come together to form dynamic access control. This is but you don't have to change the world in order to deploy it, right? You can deploy bits and pieces of it. For example, those expression-based access control rules, you can deploy those with just a Windows Server 2012 box, okay, a file server. And you can use groups, but it can use those expressions with the ands and stuff, okay? So that could be step 1, let's say. Step 2 would be, let's say you want to use central access policies. Well, that still requires the file server, Windows Server 2012 file server, and then it requires 1 or 2 DCs. Okay, now 2 because of one might go down. Okay? Now, one thing I didn't mention is that if you just want to use resource properties, all you needed to do is the AD prep, which is a schema update to Active Directory, and you don't even need to have Server 2012 domains. Okay. So then, if you want to have device claims, that requires Kerberos changes on the device, on the client. That requires Windows 8 clients. Okay. So this is a collection of some of the folks that have already done some extensibility work. I mentioned Axiomatics. They've done an XACTML translator. And folks like RSA and Data Global have done wonderful classification tools there. And then Gigi down there has done some kind of what-if analysis. We've added some what-if analysis you'll see in the ACL editor if you look at it, but they have a bunch to slice and dice your what-if scenarios. And then for Quest has added a Windows 7 version of the ACL, of the expression-based ACL UI. Okay? So there's a lot of extensibility points. I hope that was clear. And then there's a lot of folks that have already done some complementary tools to both to help in places like getting this deployed or helping with reports. I talked about the auditing. Folks allow HP, who I don't have up here, I have a really nice model to take the auditing and slice and dice it so you can say, who's been accessing my finance data? Right? Or I only want to audit my finance data and tell what non-full-time employees have been accessing my finance data. Right? So they've set up a bunch of reports and analysis tools for that, and others have as well. So in review, we set out to introduce dynamic access control. Hopefully we did. Understand the plumbing of most of the stuff there. And we did file classification, central access policies, authentication, authorization flows, and token bloat. And then we talked about extensibility. Right? So I think we're at the question and answer stage. Oh, I should point this out. The dynamic access control developer extensibility page up in TechNet has a nice roundup of all the different technologies, because there's a lot of them in there, and how to make extensions. Those partners I mentioned have very different extension scenarios. So there's a host of different ways to approach it. So I think we have 14 seconds. So that's pretty close to my time. And then, of course, there's Q&A. But I have a feeling that folks are interested in certain handouts that are going to be done tonight. So thank you.